Hey gang, TEK 10 here. Polynomials, one of my favorite units. I love polynomials. So here we go. We're going to be factoring and doing all kinds of fun stuff with our polynomials. So we added some multiple choice in here to your review. We felt like it might help you guys just add a little bit, make it a little easier. So a square play area has an area of 3x squared plus 6x plus 3. Which of the following best represents the area of this square? Okay, this is actually not too hard of one. I'm going to take this, and if I have a square and I know the area is length times width, right? So area equals length times width. If the area is 3x squared plus 6x plus 3, then I want to know what is the length and the width. Well, remember, all we got to do is factor this. So let's grab our calculator and let's see. So I'm going to use Desmos on this one. Got to get it going. Okay. I'm going to plug that in. So I'm going to do 3x squared plus 6x plus 3. All right, so there it is. Now what I'm going to do, I'm going to actually just kind of take the easy way out, y'all. I'm just going to put these in. Print 3 parentheses x plus 3. Parenthesis x plus 3. Parenthesis. Oh, so they're not directly on top of each other. So I'm going to turn this one off by touching it, and I'm going to turn on another one. So x plus 3. X plus 3. X plus 3. 3. It'll be 6. No, all right. All right. Sorry, I had a moment there. Yeah, so that one's not, so let's turn this one off and that one back on. So yeah, it still doesn't match my red one up there at the beginning. So let me turn that one off. Go to the next one. X, just plain old x plus 3. X plus 3. Yeah, that's not even a quadratic. So hopefully my last one down here will work. I'm going to turn that off, turn it on. So we've got 3 parenthesis x minus 1 times, oh, I'm sorry, plus. Ooh, hello. Plus 1 times x plus 1. Ah, looky there. Okay, so what I can do here is I can, let me delete these other ones so I can get back up there. All right. So there's the red one. If I turn off the red, I can see it's black. And then when I turn the red back on and turn this one off, you can see how they overlap. They're exactly the same. So there we go. So we know it is this one. The other option would be to note -1 is my only x-intercept. It's my only 0. X's lie. So when I plug -1 in, it would be x plus 1, x plus 1. But x times x is x squared, and I need 3x squared. So I'd have to add a 3 in the front. And it would be the same. All right, number 20, simplify the following expression. All right, we get to do the box. So here we go. We are going to multiply our polynomial. So we're going to make our box. 3x minus 2, I'm going to put that here. 3x minus 2. And I'm going to put 5x plus 7 right there. All right, so let's multiply. 3x times 5x will be 15x squared. 3x times 7 will be 21x. 5x times -2 will be -10x. -2 times 7 will be -14. Always on the diagonal, they add together. So that means I'm going to have 15x squared, 21x, and 10x. So I'm going to put up here 21x minus 10x. 21 minus 10 will be 11x. So that'll be, and it's a positive, 21 minus 10. So that'll be plus 11x. And then I have that -14 still down here. Now, if this was a multiple choice, I could have done it a lot like I did this one, just graphed it and see which one worked. All right, the area of a rectangle piece of wood is represented by this. Find the dimensions of the piece of wood. Okay, so if I have a rectangular piece of wood, and I know that area is length times width, and I give you 2r squared minus 13r plus 21 as the area, and I want to know what is the length times the width, I'm just straight up factoring this, right? I didn't leave you a lot of room there. Probably should have left you some more room. All right, hold on. Here we go. Clear all this out. Okay, so I'm going to come up here and I'm going to put that in. I'm going to say 2x squared minus 13x plus 21. My class, we always just looked for the zeros, which in this case, oh, there's some yucky zeros, aren't they? 6.342, I'm going to put them up here, 6.342 and positive 0.158. Hopefully I've gone back and left you a little more room to work on that one, because the one I'm working on, it doesn't have a lot of room. All right, so I'm going to grab my calculator. I'm going to see if I can turn those back into fractions. So I'm going to go on my calculator. I don't think they're going to. 6.342 math, enter. Let's see what we get. Yeah, we get some yucky fractions. Blech, that's not good. And 0.158, we would do math, enter. And yeah, we're getting crazy answers. So what I'm going to do, because like I said, hopefully I've left you some more room to work than what I've left myself the first time through. I'm going to go and I'm going to use my quadratic formula. So I'm going to go negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, I want to know what the area is, so I'm going to go ahead and use my quadratic. My a in this situation is 2, my b is negative 13, and my c is 21. All right, so I'm going to have negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, I was going to see if I had a black. I do. All right, so let's plug these in. Negative b, so I'm going to plug in negative 13, 2, 21, and 2. I'm going to grab my calculator and I'm going to work these. So alpha y equals, I'm going to plug it in just like it is there, negative parenthesis, negative 13. I'm going to do the plus one first. Second, square root, parentheses, negative 13, parentheses squared, minus 4, and then we're going to do times 2 times 21. And on the bottom, we're going to have 2 times 2. So it's 7 over 2. So one way I work this, I get 7 over 2. And now let's go up, remember the copy and paste, where I can put my, you can't really tell because of what mine's done, but I highlight up there and it copy and paste it. I'm going to scroll over. I'm going to change that plus sign to a minus sign. I'm going to hit enter, and the other one is 3. Okay, so 7 over 2 and 3 are my two zeros. All right. One more time, if you just want to know how to copy and paste, move this cursor up, and you can barely see it's highlighted blue there, and then it's kind of highlighted blue there, and then you hit enter, and it copy and pastes what you were just working on so you can edit it. Okay, so that means here are my numbers. So I'm going to go back over here, and I'm going to plug those in. So we got, they're positive on both, so we have x. Since these are positive, it's going to be minus 7 over 2 and x minus 3. I'm just looking, that looks like it's going to be really weird. Oh, no, that'll be right. Okay, can't leave this in the denominator. We're going to slide it up right in front. So that means we're going to have 2x minus 7 and x minus 3. I'm going to double check. 2x times x is 2x squared. 2 times 3 would give me 6, plus 7, yeah, it gives me 13. I don't know how we got these weird numbers here whenever we did it. We should have seen a positive 3. Maybe we did and I just didn't catch that. So anyway, so there is my factored form. Let me go back on Desmos and just look real quick, because I should have seen that 3. Yeah, no. Oh, you probably caught that right there. That was a 1. Looky there. Okay, let me zoom in. I didn't have that on there. So there's my 3. 3 and 3/2. Oh my gosh, y'all. I hope y'all saw that before I did. Well, oh well. Maybe I'll go back and edit that one. Yeah. 3/5 is 7/2, and 3. Yeah. These were wrong. So we had 3.5 and 3. 3/5 is 7/2, and 3 there. Yeah. All that mess right there, you did not have to do that. Oh my goodness. Okay, factor completely. Let's see if I can do this one, Mrs. Dean. All right, we're factoring. So 4x squared minus 81 y squared. I don't know if it'll do my y squared for me. Yeah, it's not gonna. So, well, let's see y squared. Let's see what it does on here. I'm gonna hit home, and then I'm gonna see if I can see it. Yeah, I think since I put that y squared on there, it's not going to let me do that. Alright, let me go over here. Let me hit home. Oh my goodness, there we go. Okay, so I can see it's at negative 4/5 and 4.5. Those are my zeros, right? Now, I did not put the y squared on here. I'm going to have to remember that I have to have a y on there. X squared minus 81. These are perfect squares, aren't they? This is actually the difference of perfect squares. All right, so here's what I'm going to do. I know if I'm factoring, they're going to look like this. My zeros are at negative 4.5 and 4.5. Okay? 4.5 is what as a fraction? So we're going to say it's 9/2. 9/2. And I'm going to put my x and my x, one positive, one negative. I can't leave the denominator down here, so I'm going to slide it up right there. So that's going to be 2x plus 9 and 2x minus 9. But 2x times x is 4x squared, but what about 9 times 9? That's only 81. What do I need to add on here? Yeah, I need to make sure that I don't forget the y. If you had one like this that was multiple choice and you were trying to graph it on Desmos, you would want to leave the y off and just work with the x. And no, the y is going to fall into place on that. You won't have to worry about it too much. Okay, so a rectangle desk has an area of this. The length of one side is 3x plus 5. What is the length of the other? Okay, so if I have a rectangle desk, and I know that area equals length times width, and they're telling me that 6x squared minus 11x minus 35 is the area. And we'll say that one of the sides is 3x plus 5. What's the missing side? Well, let's just graph it and see what it looks like. Okay, so let's put in here 6x squared. So 6x squared minus 11x minus 35. Okay. There are our zeros, so I'm going to set that to the side over here. I'm going to come over here. They're at 3.5 and 1.6667. I need to know that when you have repeating sixes, that's one of the thirds. 1/3, 2/3, whatever it might be. So this is like negative 1 and 2/3, right? When you repeat 0.666, that's 2/3. So I'm going to change this. 3/5 is actually going to be 7/2. This one is going to be 3 times 1 is 3, plus 2 is 5. So this is negative 5/3. Okay, I'm just going to change those to decimals. So if I were to plug these in, and I can already see the 3/5 they've already done, but I'm going to say, okay, this would be, I'm just kind of ignoring this right here, x times x. Since this is a positive 7/2, it's going to be a negative 7/2 here. This is a negative, so it's going to be the opposite, 5/3. Move your fractions up. So that will be 2x minus 7. Move your 3 up. 3x plus 5. So they already got 3x plus 5, so what goes here? 2x minus 7. I'll go ahead and just box it all in. Really, 2x plus minus 7 is my answer. All right, last one is simplify the following. So if I want to multiply this, if you like the box, you can always do the box, and I'll show you how we do it in our class. We take it and we draw the box, and we put the 1 right here. And since it doesn't have another one, I'm not going to have anything there. Then I'm going to have x squared minus 2x. And since I have another term over here, I'm going to just add the box over. And I'm going to put 10. The thing is I don't have anything down here in this bottom, so I really don't need this down here. 3x times x squared will be 3x to the third power. 3x times negative 2 would be negative 6x squared. 3x times 10 would be a positive 30x. Nothing's going to go together, so I'm going to get 3x to the third minus 6x squared plus 30x. All right, find the perimeter of the figure. Let me zoom in just a little bit. All right, so take a second, look at that. And here we go. Find the perimeter. Perimeter is just when you walk around the outside edges, but don't forget, these aren't labeled. This side over here is the same as this. So this is 2x plus 3. This side is 5x plus 8. Whenever I'm adding this up, I just like to just add my x's. 2, 5, 2, and 5. 5 and 5 is 10. 2 and 2 is 4. So 10 plus 4 would be 14 x's. Then I'm going to add everything else. 8 and 8 give me 16. 3 plus 3 gives me 6, right? So I'm going to add that up. That would be 22. So it would be 14x plus 22. All right, that concludes TEK number 10.